Well, hello, everybody, and thank you for joining. Welcome to Automating Networks. The fight is real with the technology luchadors, hosted by One Technology, Red Hat Ansible, and Tech Data. Today, Marshall Hall from Tech Data is going to walk us through how to automate networks, whether it's Juniper, Arista, Cisco, and then also F5. Please use the Q&A tab if you have any questions as we go, and we'll try to get them answered. If anyone has any follow-up questions, don't hesitate either. We will, Marshall, myself, the Red Hat team, the full One Technology team will be available to help answer questions, provide more content for your teams, etc. So with that, I'd like to introduce Marshall Hall, who's going to be leading the workshop today. Marshall?
Hey, thanks for the warm welcome, and welcome to the workshop. Let me share my screen. And all right, so we're going to be talking today about network automation with Red Hat Ansible and the automation platform. So just before we get started, I'm going to throw a link into the chat, and this link is for the workbench. And let me so this is the page that you'll come to, and at the bottom is where you would register for your workbench. So you'll just type in your name and your email address, and we're not keeping this for any other reason other than just to assign workbenches after this workshop gets shut down. All this information is going to be deleted. So feel free to enter in your information without fear of it being used, but it doesn't really matter what you enter into those two fields. It just creates a cookie in your system and creates a little placeholder for you so that you have that workbench. So I got workbench number 2. So this will be all of the access information that you'll need for all the exercises. So if you want to do that while I'm working through the slides, so we don't have a ton of slides. Hopefully we'll be able to get through most of these really quickly, and then we'll get into the meat. We'll get into the actual hands-on keyboard exercises. But what we're going to be going through today is we're going to be just doing a quick introduction to Ansible Automation. Then we're going to talk about how Ansible works within network automation. Then we'll get into Ansible modules and playbooks, and we'll talk about templating with Jinja, and then we'll move into Ansible Tower. And that's where I think the power of Ansible really shines through, is in Ansible Tower. All right, so I think we already covered the introduction. So when we talk about automation, automation is a big thing nowadays. And if we think about in our personal lives, we have all of these automation assistants that we use, Siri and Hey Google and Alexa, and we're automating just everything possible in our, well, a lot of people are automating a lot in their personal lives. And we see this also in the business world and our IT departments. And we can really think of automation as a statement here says, that automation happens when one person meets a problem that they never want to solve again. And these happen to, are typically repetitive tasks or things that just, are kind of things we need to do to keep the lights on, things we need to make our IT environments work properly, but they're not tasks that are really suitable for our skilled engineers and our skilled technicians to be working on, because it just involves pushing buttons or making sure a certain sequence happens. So that's where automation comes in. And when we look at our organization right now, there's probably a lot of automation already happening, but this automation is happening in silos. And so we see the different options that different groups might be using, from do-it-yourself scripting to open source management tools to proprietary vendor solutions. And what happens, what's we see happening is this automation is not organic enough, and each group is automating a different way at different speeds, and they're having different results, which is creating an uneven view in management's eyes of the benefits of automation. And so that's where we bring in Ansible. So Ansible as an automation platform has these three basic tenets, these three basic pillars that I think make Ansible stand out from the rest of the automation crowd. And the first one is simple. And Ansible is simple because it doesn't require a special language, doesn't require special skills. We can use the skills that our IT teams already have, and we can get up and be productive very quickly. When we think about the power of Ansible and the Ansible automation platform, we can really orchestrate the entire app lifecycle or infrastructure lifecycle. And so we can use the power of Ansible which can really just address anything that's on the network. And here's a few examples: app deployment, configuration management, workflow orchestration, and of course our the topic for today, network automation. And there's a lot of benefits to the power of Ansible and being able to do this automatically. And then the third point is agentless. And this is one of my favorite parts. I have a deep background in monitoring and remote management. And we had a lot of systems that had these agents. And it was just a real challenge to keep those agents updated and keep them secure. And I was worked in environments where we had tens and thousands of these agents, and just doing a security upgrade would sometimes take a week, 2 weeks, 3 weeks, especially when some of those agents were not connected online, or there was some other issues happening within the environment. So also not having an agent brings up reduces the ability for Ansible or for someone that gets a hold of that agent to exploit the system. And it also makes it easier to get going, because we don't have to spend time in the engagement phase deploying agents just to make the product work. So we talked a little bit before about what we can do using Ansible. And if we look at these 6 categories, we see orchestration, configuration management, provisioning, continuous delivery, security, compliance. Those all 5 fit, and possibly even application deployment, fit into our network management automation model. And we can automate these things. We can automate firewalls, we can automate load balancers, network devices. Like I said before, anything that can be addressed on the network, Ansible can pretty much automate. So when we have this automation happening across an entire company, it makes sense to have an automation platform. And so that's where the Red Hat Ansible Automation Platform comes from. And so we have these 3 layers of the automation platform. And the first layer is the Ansible Engine, and this is the heart of Ansible, and this is what does all of the work for us. And then right above that, at the scale level, is Ansible Tower. And Ansible Tower allows us to extend the capabilities of Ansible Engine and allow us to use role-based authentication and have security built in for our credentials. And there's a lot of benefits to using Ansible Tower, and it allows us to scale Ansible out for the entire enterprise and use that in a safe and secure manner. And then there's the Engage level, and this is Ansible secure software as a service offering. And this is a way for companies to utilize Red Hat's infrastructure to deploy Ansible anywhere in the world and automate regardless of location. So when we look at the technologies that Ansible automates, here's just a few examples of some of the major technologies and vendors that Ansible works with. So hopefully you see your vendor or your technology listed here. And when we think about the return on investment and why we should use, or what's the benefit of using the Ansible automation platform, and I'd just like to point out on the right side 146% return on investment with Ansible Tower, typically in less than 3 months. And I know at the bottom, the study's a couple of years old, but these numbers, I think they still apply. And then we can see on the left side, the reduction in man hours required, or the savings that companies achieved when they were using Ansible Automation Platform, and they're pretty significant. So that moves us into our network automation use case. So when we took a look at how are companies working with their networks, how are they configuring their networks, and 2 years ago we found that 71% of networks are still driven by CLI, and that's pretty amazing considering all the advances that we've seen with software-defined networking and a lot of other technologies that have been that are meant to ease the operation of a network. And to think about how 71% of our operators are still manually configuring for the CLI is pretty amazing. So when we think about our modern data centers, they're not as simple as they used to be, and it's been that way for quite a while. And so, if we think about small configuration changes that are incorrect or that are fat fingered, can ripple across a large environment very quickly and cause significant problems. And we've all seen when those problems happen with various public cloud providers as they go offline and have these opaque reasons for what happened. So again, we come back to the why Ansible, but with a little bit of a network spin. And I won't go through all the points in the slide because they all still apply to networks. But on the agentless side, and I know I said that was one of my favorite parts before, but the no agent aspect makes this ideal for working with network equipment that doesn't have an operating system that we can add to or manipulate. So if we think about most network equipment comes with a base image or a vendor supplied image that we can make very few changes to that image itself. We can only configure the product or configure the network device. So we're not able to deploy an agent on that. So Ansible is great for that, and that's it makes it ideal for network equipment. So when we think about Ansible network automation and what's available, there's two places where the content is maintained, and Ansible Galaxy, which is at galaxy.ansible.com, is where the community contributed content is. And within that, within Ansible Galaxy, there's 65 plus network platforms that are supported. There's thousands of network modules, and there's 15, actually there's probably more than 15 now, but there's 15 or more Galaxy network rules. And we'll get in a little bit what these rules do later in the workshop. So when we think about what are the use cases that we can use automation for, and like I said before, automation, if we think of automation as a way to free up our valuable human employees, especially our higher paid network engineers, network operators, network technicians, whatever you want to call them, doing things like backup and restore, or dynamic or documentation. Those are things that we have to absolutely do. We have to keep track of our configuration compliance. But are those things that we want our senior network engineers doing, or do we want to have to hire additional employees that are lower level network operators to do that? And what automation allows us to do is it allows us to reliably do these common use case functions without having to dedicate an expensive human resource to it. And we can have the automation take care of a lot of these keep the lights on activities. So we can free up our valuable employees And I think of all of our human employees as being the most valuable resource. And coincidentally, they're probably one of the most companies, that's the largest expense of any most modern companies is their employees. So we can free those employees up. We can free up our valuable resources to do value added things for our companies and our organizations, rather than doing things like backup and restore. And that was when I was early on in IT. I always heard the jokes about someone being the tape jockey, and that would I worked in a couple of companies where we had one person, his whole job or her whole job was to just take tapes out of the backup system, label them, make sure they get off to the offsite storage, and it was just a lot of human power put into kind of a menial task. And everyone always talked about how that's kind of like the punishment. But wouldn't it be great to be able to push that off on to a computer system and have Ansible do that? So when we think about how Ansible network automation works, and thanks for listening to my little diatribe there on the tape jockeys. And sorry if anybody here is in charge of the tapes. I know it's a thankless job. But if we think about how Ansible automation, network automation works, so I'll start at the bottom with how Ansible typically works. So this is for systems that have an operating system that we can modify or we can add software to, such as a Linux or Windows host or a workstation or server. So what happens is the Ansible engine, the control node, will connect to each one of those systems, and it'll use native authentication that's available. So if we're using Linux, we'll use SSH or other Unix systems. If we're using Windows, then we use the WinRM module or other ways to connect to that host. And then the code that's going to be executed is copied to the host in a temporary file. It's executed, and then once it's completed, it will remove that code from the node. So when we think about a network device, let's say a Cisco router, Cisco iOS is not really amenable to us installing an agent or uploading software to it. And we also have a very limited amount of space, typically on networking devices for such activities. So what Ansible does in that case, the control node or the Ansible engine will execute the code itself against those networking devices. So it makes it very modular, and it makes it very easy to work with both in the same environment. All right, so now we're gonna, let me back up. So now we'll talk a little bit about the first level, the create level of the Ansible automation platform. And this will lead us into our first exercise. So the Ansible engine is comprised of various components, as you would imagine. So if we look in the middle, the Ansible automation engine really starts with the inventory, and it's command line driven. And we have modules and plugins, and I think I have a couple of slides on how those work. But on the left side, we have the input to the Ansible engine. So this could be users executing a playbook, or it could be inventory coming from a CMDB, or it also could be output from our cloud providers or from our private cloud. And then it goes into the Ansible engine, the instructions that we want to do, and it will automate network devices, hosts, and those can be in a regular data center that we manage. They can be in a public cloud or a private cloud. So our playbooks are written in YAML, and each of the tasks are executed sequentially. So this makes it very easy to use and to read. So when we read an Ansible playbook, we're able to we're able to understand exactly what Ansible is doing. And like I said before, this doesn't require a ton of time to learn a new syntax or learn a new language. It doesn't require 4 years of school on this specific thing to get going. So playbooks are really easy to understand once you understand the basics of them. Then we move on to modules. So these are modules are tools in the toolkit, as we can, if we can think of them that way. And so modules provide the ability to extend Ansible to anything we really need to do. And so I mentioned there's a couple of different places back on the Galaxy slide. Then there's also the Ansible Automation Hub, which is at cloud.redhat.com. So the difference between the community provided content through Ansible Galaxy and then the content on the Ansible Automation Hub is Red Hat's ability to support their ability to support that. And if we think about the community contributing content through Galaxy, and then Red Hat engineers or Red Hat developers going in and cleaning that up, verifying that it's going to work the way it's expected, and then supporting that on the back end through the Ansible Automation Hub. I mentioned the inventory before. This is really the one of the core pieces of Ansible, having an inventory. And this is really just a list of systems in our infrastructure that we can execute automation against. And so when we look at the inventory file, so there's multiple ways to do the inventory. We can have a static inventory, and that's what we're going to be using in our workshop today. And our static inventory is just a flat INI file. And if we look at how this is put together, so we have the first column is the host name of the device. And then we have 4 here that have this Ansible _host variable appended to it or added to the end. And what this is telling Ansible that instead of using whatever RTR1 or 2 or 3 or 4 or 5 or 6 resolves to in DNS, that we should use this address for the Ansible host. And we'll see in our workshops that this is a way for us to give it an explicit IP address or an explicit, typically we use IP addresses here, but we could also give it a host name if we wanted DNS if we wanted to resolve that through DNS. But what this gives us is the ability to address nodes when there may be multiple interfaces and we want to hit a specific interface. And so our workbench environment, our exercise environment, is built on AWS. So if you're familiar with AWS, there's a private address, and then to make that public, we link a public address to that. And so when we look at our inventory, we'll see that the public addresses are in that Ansible host field. And so within our inventory, we can also have groups. And so those have the square brackets. And so whenever we see the square brackets, it's a group of some type. So we can also have groups that nest other groups. So our examples here, we have Cisco, Arista, and Juniper as groups. And then we have a group at the bottom that has all of our routers in it. And so, and the power in doing this this way is that we can execute playbooks against just all of our Cisco, Arista, or Juniper assets, or we can execute automation against all of our routers. And we'll see in some of the later examples how we can do that. And then we can also have variables. I talked a little bit about the variables already, but we can have variables. And if we apply them on with the host, then those host variables are going to apply for that host. But at the bottom here, we have a group name with vars after it. And that tells us that we have group variables. And so group variables would be would apply to the whole group, as they imply, but they also I guess there's no also there. They apply to the whole group. Group variables are typically for providing the access method or other information that we need to connect, and then the specific host variables are typically information that we need for that specific host to connect. There are some reserved variables within within both fields, within either host or group variables, and those are listed in the documentation. Outside of the reserved variables, we can use any variables we want, and then we can use those in playbooks should we need them. And then just to take a look at a quick example Ansible playbook, we'll see that the first line has 3 dashes, and that's just to tell Ansible that this is a YAML file. And then our next field is the name of the playbook itself. And then we'll address which hosts are going to be affected by this playbook. And then the gather facts. So gather facts is really something that's designed for systems where we can copy the code to the server workstation, and it really doesn't apply to network devices. So for all network devices, we're going to always set this to no or false, and Ansible will accept either. So you can we'll see in the exercises that gather facts is set to either no or false in all of the examples. And then we have the tasks, and so each task has the same similar format where we'll have a name, and then this NXOS underscore VLAN is a module, and these are module arguments. All right, that brings us to our first lab. And with that, I will get you going on the lab. So, all right. So when you're working with the workbench, there's 3 ways you can access the environment. So we can just click on this link for the Visual Studio Editor, excuse me, and this will open up a screen that looks like this. And what we can do is we can go to Terminal and New Terminal, and this is just like you were on the console of the server that is assigned to you. So within our lab environment, we have a workbench. Everyone has their own workbench. Nothing is shared, so everyone has their own 4 routers and their own control node. So so that's one way to access it. Then we can go to PuTTY if we want to access it. If you have an SSH client, and you can just copy that into the connection information. Yep. And then we just need to copy the password. And there we go. So either way is fine. I'll use the Visual Studio Editor just to make it easier on your eyes. But I'll move that off the screen and bump up my resolution a little bit so be a little easier to see. So that's how we access the environment. Then the bottom credential is for Ansible Tower. And so when you go to that, you'll be prompted for the login. And I know it's bad security policy to have the same password for everything, but we did it. We created everything with the same password for each user so that it would just be easier for the workshop. So in production, we wouldn't have the same thing going on. So all right, and then at the very once we get access to the environment, at the top is the Ansible Exercises, and before I go into the first exercise, this is the network diagram that we're working with. So we have our control node on the left-hand side, and then we have our 4 router devices. And each of these routers are connected by out-of-band management, as well as we have the ability to route in between those managements, or in between those routers. So when we start the first lab, and maybe I should have said this earlier in the workshop, but the way that we'll do the exercises is so that we can keep everybody engaged. If you have any questions, feel free to throw them into the chat or Q&A, or if you have any problems. The first exercise, what we'll do is we'll go through, I'll give you a little bit of time after this first exercise. I'll give you a little bit of time to start off reading the objective and some of the other parts of the exercise, and then I'll start doing a walkthrough with you. So here's the network diagram again. So we have our control host, and then we have our 4 routers that we're dealing with. And it's very important, or it's not so important, but we have an SSH file set up for each of these routers. So you'll be able to go to each router and just type SSH and then the host name, and it will automatically connect. So we don't have to enter a username or password. And so there's just one hint on how that works. And so, yeah, we can go and just SSH to router 1, and we're automatically logged in. So we can do that for all the routers. So it makes it very handy, and just so that we know that we're doing the same thing on all of them. There we go. Oh, let me exit out of here before I restart someone's network. No, I'm just kidding. So there we go. So let me get my speaker notes up. So when we take a look at the, just to make sure we're on the correct host, you should be on Ansible 1 or Ansible dash something, and your student plus your number will be there. So whatever workbench you got assigned will be your new number, and that's how we know that we're on the correct server. We're on the Ansible control node. And so the first part of the exercise is to change directory to network workshop. And so if you're familiar with Linux, the tilde sign is the shortcut for our home directory, and CD just changes our directory. So so there we go. We can do a PWD and see what directory we're in. If we ever have if there's any confusion. Sorry about that. A little bit of a tongue twister. And the next command we're going to run is Ansible -- version. And this is a very helpful thing if you're having issues, or if you need to find some key information about your Ansible environment. So for right now, this is a pretty simple environment that we have set up. But as you move into Ansible in your own environments, the Ansible -- version will have a few pieces of key information. The first one being the Ansible version. So we always want to make sure we know which version of Ansible we're running, because the documentation is usually specific to a specific version of Ansible, and there's a lot of changes that happen between versions, a lot of updates. And so if something, if you heard about a great new feature and it's not working, or if it worked the way it used to work but doesn't work anymore, we can look at the Ansible version and figure out what's going on. The second piece that's very critical is the configuration file location. So this is telling us which config file we're using, and the config file is it controls how the Ansible engine operates. The rest of this information is interesting if you start having problems and need to troubleshoot a little bit further, but it'll show you which module search path, you're using, which Python module location you're using, and the Python version and location, or the executable location. So if you start having problems, the rest of that information is helpful to troubleshoot. All right, so now we're going to take a look at the Ansible config file. And so we'll take a look at that. We'll just do a cat on that, and it'll just display the contents of that file. And so most of this stuff is not really important for us to understand what it does, but what we're looking for is the inventory file location. So this will tell us where our inventory file is located, and it's very helpful in that regard, because if we're executing against a specific inventory of hosts and our host isn't in there, then we're gonna have some issues. So the next part of the exercise is to, can't put any extra dots in there, but we're gonna cat the host file. And so as we saw in our example, we have some starting here. I don't know if I mentioned it before, but there's a default group called all, and that's all of the hosts that are listed in this inventory file. So we see at the very top, we have a variable for the all group, and we're just telling it where the private key is, so we can SSH to everything. And then we have our group of groups with routers, and then having children of Cisco, Juniper, and Arista. And then we have our Cisco, Arista, and Juniper hosts. And then we have some variables for each one of those. And then we have some other groups at the bottom here that just have specific hosts and put together into data centers. So very interesting on the host on the inventory file. And there's some more discussion in the exercise about what some of the variables are, and I won't bore you with my Ben Stein reading of them. So with that being said, are there any questions? I guess I should pull up the chat and find. All right. And does everybody have a workbench? Oh. All right. Fantastic. Well, let me find where I was in my presentation, and all right. Yeah, that's where we left off. All right, so heading into exercise 2. I'm gonna go through the slide part of it real quick, and then we'll take our first break of the day. So we'll take a couple of breaks today, just to give everybody a chance to stand up and exercise your legs, or get a drink, or visit the facilities. So for exercise 2, we're going to be running our first playbook. And so this is a playbook. We really don't have to understand the how everything's put together right now. We'll be building a playbook from scratch. Well, not really from scratch, but sort of from scratch, a little bit in the next exercise or two. But we just wanted to take a look at the just how this playbook is put together. And so, like I said before, we have the name parameter, and this is the playbook name parameter. And so with these names, we want to put something in here that makes sense or that means something, because this we'll see in the output how these are being put into the output, so that it'll help us to keep track of, especially as our playbooks get more complex. then we can understand where things are happening, what it's doing, and if we have any problems, we can troubleshoot from there a lot easier. If we have something that doesn't really make any sense, or just numbers or whatever, that's going to be very more difficult to see what's going on, but also to look at that output and make any sense of it. Like I said before, we'll use the hosts to target which group we're going to use. And so within a playbook, we have to put something in the host category. But in practice, what we'll do is we'll use either a command line argument, or we'll use Ansible Tower to limit what it's actually doing, or limit the host that's actually working against doing automation. And then again, the gather fax. And so for network equipment, we're always going to set that to no or false. I know, even though it says optionally, but even if you set it to true, I don't think it's not going to do anything because it can't. So when we take a look at the modules, so within this example, the iOS_config is the module. And what this is doing is it's sending these commands, SNMP server community, and then it's setting these two community strings. So as the slide says, most of the modules are written in Python, but it's not limited to just being written in Python. You can really use anything you're comfortable using. Python is just the common language that is used most frequently in Ansible. And then modules can be idempotent. And this is a fancy word for saying it's only going to make that change once. So if we run this playbook over and over and over and over again, it's only going to send these two commands to the router the first time, or the switch, or whatever it is. It's only going to send that the first time, and then the second time, and each subsequent time, it's going to check to see if those two community strings are there. And if they are, it's just going to say they're already present, no need to do anything else. So within the networking modules, we have vendor specific modules, and then we have so we have these three general modules. We have fax modules, command modules, and config modules. And these all do very similar to what you think they might do. So the fax modules gathers facts about each device. The command module issues a command similar to how you would issue it on the command line. So you need to, to use the command module, you need to make sure you understand how to issue those commands on the specific device. And then there's the config modules. And these modules, as they imply, do configuration. So we have vendor-specific modules, and here's just some examples on the right-hand side. So iOS is going to be for Cisco iOS, EOS for Arista, JuneOS for Juniper. So it kind of follows a little bit of a pattern there if you're seeing it. So we'll also talk about some generic modules that we can use to address multi-vendor environments. All right, so when we run a playbook, we'll use the Ansible-playbook command, and we'll give it the playbook name as an argument. So we're just going to be running it really simply. And so when we run a playbook, let me back up a little bit. When we run a playbook, this is the typical output that's going to be displayed. And so if we look at the names here, that says play, and it displays the play name. And then for each task, it plays, or it displays the name of each task. So this is where I said before that we want to make sure we're using names, or we want to put descriptions that make sense to us, so we can keep track, or we can see in the output what's happening. And then we can also add the -v, and we'll see how this works in the exercise. But when we do the -v, it'll display much more information, and we can keep adding V's to increase the verbosity. I should know how many V's you can put in there, but I'm sure it's limited to some level. I just don't know what the limit is. And that brings us to our second exercise. And also, I'd like to take a stop for our first break. So it's a 9:48 Mountain Time. So let's come back right before 10 o'clock, and we will pick up this exercise. And if you have any questions or anything, feel free to throw them into the chat or the Q&A. And with that, I'll let you get on to your break. All right, let's dive right into the exercise. So we got to the end of exercise 1. And so if the end of exercise 1 is the link to go back to the main exercises, and then we'll start at exercise 2. All right. So for exercise 2, we're going to be taking a look at we'll take a look at the Ansible playbook again, and then we'll execute that playbook. And we'll also talk about a couple of modes of the Ansible playbook command. Specifically, we'll talk about the check mode and the verbose mode. So I'm already in the network workshop directory, but if you happen to change directory out, we'll want to change directory again. And if we take a look at our home directory, we have our lab inventory file with our inventory file in it, our lab inventory directory with our inventory file in it. But we also have our network workshop directory, and that's the workshop. That's the directory that we're in. So if we take a look at that, there's 9 folders, and each one of these folders have more or less the answers to each of the exercises. So we'll have all of the playbooks and some additional information. There's some the supplemental directory, which has just some supplemental material, and then on the exercise page, if we go back, if I just go back for a second, so here's the supplemental exercises that are located here. So if you click on that, there's another 8 exercises, and these are extra credit exercises, if you will. So you can work on these on your own if you'd like to. There's some more advanced and some other use cases that are introduced here. And so you'll be able to do the, if you're interested, you can take a look at some of these supplemental exercises. The environment will be up until midnight tonight. So you'll have the rest of the day after the workshop if you want to log in later in the afternoon or evening to continue working on exercises or to do anything else. This is a full environment that you can abuse and tear apart as much as you'd like. But at midnight it goes away. So back to our exercise 2. Let me here. So we'll take a look at our playbook.yml file. So it's very similar to what we saw in the slides. I think it's exactly the same, except for the gather facts is set to false instead of no. And what we're doing is we're just going to send these 2 community strings to the router to configure those. And so we can take a look at just so that we aren't cheating. So I logged into router 1, and if we look at the running configuration, and we'll pipe that into this command, we'll take a look at it. So right now there's nothing in the configuration with SNMP. So we're not cheating, hopefully. What we'll do is we will run this command. So you can copy and paste. I hope you nope. The copy and paste works in Chrome if you want to use if you use Chrome. And maybe I'll switch to Putty so that I can copy and paste a little bit easier as we get into some of the further exercises. For some reason, it doesn't like it on Firefox. So, but we'll run the command Ansible Playbook, Ansible-Playbook, and then space and then playbook.yml, and we see that we have one change on router 1. And so these are it's going to be color coded, the output. So when we see yellow, that means that a change has been made, and it'll show us in yellow the host name that the change was made on. If nothing was changed, it'll be green. So if a configuration was checked, but no change was made, it'll be green. And then if something fails, it'll be red. And there's a few other colors that are described in the documentation for tasks that are skipped and some other things. But those are the 3 main colors we need to worry about: green, yellow, red. So green is something was checked, but nothing was changed. Yellow is something was changed, and red is something failed. So we just changed the community string, so now we can log back into router 1, and we can do the old, if I can type, show run command. We'll pipe that to the I, and now we see we have 2 community strings set. So so there we go. So I talked a little bit about idempotency, and that's really the ability that for Ansible to understand that a configuration doesn't need to be changed. So if we go through and run this playbook again, the second time we run it, the third, fourth, fifth time, it's just going to go in and check those 2 community strings are set, and if they are, it's just going to tell us that they are okay and no change was needed. So we see that with the green, and we can run that over and over and over again. And so that brings up an interesting use case that we'll talk about a little bit later. So the next step is to add a line. So we're going to go ahead and modify this. I'm using VI, but you can use whatever editor that you're comfortable with. You can also, within the editor, you can also go to open file, and then we'll take a look in our network workshop directory and playbook.yml. So we can also add it here as well. So dealer's choice. Go ahead and quit that since I made a change. And with Ansible, or with, it's really not with Ansible, with YAML files, there's a big dependency on the correct indentations. So each one of these indentations is 2 spaces. So it's not the tab key, it's not anything else, it's 2 spaces. So when you're going through and putting these together, make sure you put your tab key away and just use the space bar. But this is, what is that, 5 indents? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And so this is a list item. So we're going to go ahead and give it the list item for a new list. And we're going to change community, and then it's going to be, and we're going to make this read only. So we're going to set another community string. And if you're doing it the same way that I'm doing it inside of the Visual Studio editor, then once you finish it, you can just click on save. and we can click the X there. And so, all right. So it also says you can use Nano. So if you're working in Nano, so there we go. We have the change made. So we can also within Nano, it's what is it? Control O to exit, or to write the file. Control X to exit. So there we go. If you're using Nano, if you're using VI, it's WQ and Q, or W and then Q. So, all right. So the next thing we're going to do is we're going to run our playbook again, but this time we're going to give it the -- verbose and the -- check commands. And so when we run this, the verbose is going to display the output from the playbook, and it's going to display more playbook. So we see that we have a certain amount of verbosity here. So it's showing that what our Ansible config file is, and it's also showing that this is this router would require a change. Since we ran it with the -- check option, these changes were simulated. So it went through and acted as if it were going to do a change, but it didn't actually issue the command to the router. So this is where the interesting use case for the idempotency of the playbooks comes in, because now we can use the check option to check configurations. So this is we're checking that the community strings are set, but by using the check option, if a community string needs to be changed or is not the way we want it to be, it's not going to actually change that. It's just going to tell us. So we could set this up and run this against all of our routers, all of our switches, or whatever, or make sure all of our community strings are set the way we want. And we can also see if there's any changes that have been made. So just to keep us all honest, if we log into router 1 and we do the old show run and pipe that into the I command, we'll see that we still have just 2 community strings. So even though it said one was changed, this is just indicating, because we use the -- check option, this is just indicating that a change would have been made. So there we verified that on the router. So then we'll run the same command again. We'll just take off those 2 options, and we'll let this run again. It's checking, and there we go. And then we're going to log back into the router. And so this is why it's great to have the SSH keys already set up. So we're going to do a show run and pipe that into the include command. I believe that's what the I stands for. So we're looking for everything that includes SNMP. And so there we go. There's our 3rd community string that was added. So so this was using the let me pull back up the playbook. And so this was using the iOS config module within the Visual Studio Code Editor. It has some helpful syntax highlighting and some other information. So we can see we can mouse over each of these, and we'll get some help should we need it. Now it's being shy. But this will tell us where the documentation is, so we can do that. The next exercise will be going a little more into the Ansible documentation. So, but we can see how this is like I said before, this is a powerful way to check our configurations without having to actually change anything. And then we can go back through and review those things that should be changed or we'd like to have changed, to make sure that we're not stepping over somebody, or someone didn't make an approved change that we're unaware of. There's a variety of reasons why configurations change, and sometimes you just never know. We had a great instance at one of the companies I worked for, where one of the guys, we sent him off to network training, and he came back, and he used our network as his continuing training ground, and he ended up putting a couple spanning loops into our network and shut down chunks of our network. And great fun. The days of running on the command line are just great fun. So with that being said, that's the end of exercise 2. So we'll let me pull up my slides again. All right. So that was exercise 2. And we're heading into exercise 3 now. So I promise as we get further and further into this, there's less slides and more exercise. So there's documentation for Ansible. And so you can go to ansible.com and find the documentation. And you'll see that in the top here, it says Ansible 2.8. We can select latest. And that's where the version is important, because there's documentation for each specific version of Ansible. And like I said, as they add new features, deprecate old features, that'll be in the documentation. And so you'll want to be sure to use the same documentation for the version of Ansible that you're using. And so the documentation is very, very helpful. It's really easy to work with, and it is required when the community contributes modules. So we can be assured that there's some sort of documentation for every module that's out there. The other way that we can get the documentation is through the Ansible-doc command. And with this command, we don't need to worry about which version of Ansible we're running, because it's going to give us the correct documentation for the version that we're running without us having to do anything to do that. So this is a very helpful way to look at documentation for, if you're writing a playbook and you just need to check on something, or see what arguments are available for a module, then you can use the online. It's a little bit easier than going to a separate browser and looking up something else. So like I said before, we have fax modules. What these modules do is they gather the fax from each router or each network device, as it were. So we have a fax module for each of the vendors that are out there, or each vendor that has a different format, which is, I think, pretty much everybody. And we see that as prefixed with the vendor prefix that has been assigned. And so what the fax modules do is they return information about the router or network device. They return it within a structured data format. And so just some of the examples here, we have all these normalized variables, so we can use the same variable type in our playbooks without regard to what the actual thing is called within that system. So it just normalizes our data for us. So we can have an apples to apples comparison, or we can use the same variable within our playbooks that go across multiple vendors. And so if we see that they're all prefixed with Ansible _ something, and so the amount of information gathered by these fax modules is pretty extensive. It pretty much will gather all the information about that network device. So here's an example playbook. So we don't have to give the iOS fax any arguments for it to work. We can just give it iOS fax, and then it will gather those fax as the module name. And so as we're going through the exercise, we'll see that the power of the verbose, because when we run just the fax command or just run the fax module, it's not going to, it doesn't output anything. It collects that information and then uses it internally. And so when we use the -verbose option or the -v option, it will show us all of those Ansible facts, and we'll see in the exercise how that works. And then when we want to, if we wanted to output this information, say if we're generating something that we're going to put into a report, we can use the debug option. And the debug option allows us to output messages to the standard output or into the log if we're using Tower. And so then we can use variables here to output different parts of the Ansible facts that we collected. And so here's what it will look like. And I know it's a little bit of a cheater thing, but this is one of the ways that we can use Ansible to build reports. And so we can have Ansible go out and collect all the information, and we can use the debug command to somewhat format it into how we would like to present it or keep track of it. So, you know, if we think about the task of documenting the network and keeping track of all the changes that are made, Ansible really makes it a great way with these fax modules. And so that brings us into exercise 3. So I will, there we go. So we got all the way to the end of exercise 2. And if we'll go back, we'll go to exercise 3. And this is the beginning. I'll give you everyone a minute or so to just read through and start working on it before I start the walkthrough. Sometimes it's a little challenging with someone chatting in your ear to read and type at the same time. I have kind of that same challenge when I'm presenting sometimes, but anyway, I'll give you a couple minutes and then I'll give you a minute or so, and then I'll dive right into it. All right, so this is moving into exercise 3. So I'm going to go ahead and switch over to Putty so I can just copy and paste. All right, so the first part of the exercise is to do the Ansible doc, the Ansible -doc command. So if we take a look at the debug documentation, it'll tell us what the debug module does. And then it'll also tell us if any of the options are mandatory with the equal sign. So none of these are mandatory. So we could use the debug option without any arguments. We just wouldn't get a whole lot out of it. The other thing it wanted that's in the exercise is to take a look at the iOS Fax module. And so here's all of the arguments for this module. We can see there's some deprecated arguments and just some other stuff. So there's a question in the exercise about something about how can you limit the fax. Not sure what I was typing there. So This brings us to our building our first playbook. I'm building our second playbook. We're gonna call this fax.yml, and I'm using VI. But feel free to use the editor of your choice. So we're just gonna paste that in, and like we said before, the first line just tells us that we're is a way for us to tell Ansible that we're using a YAML file. The next line is the name of the playbook and the hosts that we're going to operate against if we don't give it that on the command line, and then the gather fax is set to no. And so now we're going to add our first task, and I believe it's our only task. So there we go. The spacing doesn't really matter if you want to put a no space in between the tasks or a couple spaces. It's just helps it to be a little more readable if you put a space in between each of the tasks. So, all right. Make sure I didn't mess that up in any way, shape, or form. All right. So what we're going to do now is we're going to run this playbook. So we run the playbook, and it's doing its thing. We've got a little warning there, but we can just disregard that. And when we ran that task, or ran that playbook, we just get an OK for router 1. And so where did the fax go? So if we, and this is where the verbose option comes in. So now if we run this with the verbose option, we can see all of the fax that it gathered with that fax module. So we can see all the network information, information about the image that's installed, how much space is available, how much space is in total, interfaces, virtual networks that are set up. So we gather a lot of information from the router or switch or whatever network device is with the fax module. And so that brings up the debug statement. So we'll use the debug statement to output the information that we want to take a look at. So this is where we can start creating reports and start formatting this for those reports. So we're going to add the statements to display the version and display the serial number. And so, and that's going to be done by taking the Ansible net version and Ansible net serial number from that fax that we just saw. So let me save this. And so if we look at the Ansible net serial number, it's going to be there, and the Ansible net system is going to be there. Net version, I think. Net version is what we're looking for. Yeah. So right there. So we'll be able to see what version of iOS we're running. And this would be very helpful for a variety of reasons. So let's see. So now if we run this without the verbose, it's going to go through, collect the fax, and then the debug statements, we're going to output the information that is relevant to us. And so we see that check the fax, and then for router 1, it displayed the iOS version and the serial number. And that is the end of the exercise. So this is a real great way of showing the use of the fax command to build documentation and to look at the network look at our network configurations and make sure that they're consistent to our policies that we've developed. So, all right. Well, that brings us back to the slides. All right. And it brings us to exercise 4. So in exercise 4, we're going to be taking a little more of a look at group variables, and then we're going to get a little bit into templating using Jinja. So this is a great exercise that will help us to understand how we can automate some of these big configuration changes that we get ourselves into, or that we find ourselves needing on occasion, automate large amounts of either network provisioning or network changes. So when we take a look at group variables, these are variables that have something in common between multiple devices, or with everything within a group. So we can have group variables for either just a standalone group or for nested groups. And there's some examples here of different information. We saw in our inventory file, we had group variables just saying what the system was, or what the access method was. So we have already talked a little bit about the inventory versus group variables. And there's also, so within, let me, so we talked about, let me move this to the net. All right, let me just get back to the network workshop. So this network workshop directory, when we get into the next exercise, this is the last exercise on Ansible Engine. When we get into the next exercise in Tower, we'll see this visually, what I'm talking about. But this network-workshop folder is what's considered a Ansible project. So within this directory, we can create additional directories that would hold various pieces of information, and we can create a group variables directory that would have one or more YAML files that would apply to the inventory, or that the inventory file would append onto itself to get those variables. So we can configure these in either the inventory file, or we can create a group vars directory and do it that way. So we talked a little bit before about the inventory variables are the variables that we use to connect and authenticate to the device, and the group variables are variables for things that we can configure on the device. So here's an example of a group variables file, and this is just showing the loopback interface for each of our 4 routers. And if you'll notice, the name of the file is all.yml, so we can name this either with the host name, or we can do some other great things within that directory. And moving into Jinja 2. So Jinja 2 is the templating engine that Ansible uses. And what this does, and we'll see in the exercises, this takes the configuration that we want to have in place, and it's able to take that information and put it into the correct format for each of the different vendors and make those changes. And we'll see how this works in the exercise. But within the configuration modules, we have a CLI underscore config module, which is vendor agnostic. So we can use that module to address any of the other vendor specific modules. And what it does when the CLI underscore config runs is it determines which of the specific vendor config modules it needs to use. So it's a bit of a wrapper for all of the config modules. Makes it very helpful, like I said, in multi-vendor environments. So now we don't have to write playbooks that are specific to each vendor. We can write one playbook that does a task, and then we can plug in any of the vendors that we have using those commands. So for our templating example, we have our variables on the left-hand side, and then on the right-hand side, we have our Jinja 2 template. And what this is going to essentially do is take these variables from the left-hand side and plug them into those variables on the right-hand side. And when we generate the network configuration, or when we send this off to the network devices to be configured, it's going to generate that configuration for each router based on the vendor that we're dealing with. And so here's the template code itself. This will be discussed in more detail in the exercise, and I won't bore you by reading all of it to you. But these brackets with the percent sign, those are the opening and closing indicators for Jinja code. And then the interface and IP address down below that, those are the static parts of the configuration that we can put into the template. So we could really use Jinja 2 template, just anything that has a configuration file. So if you were to think about a web server, routers, switches, anything that has a configuration that follows some sort of syntax, we can use Jinja to template that. And so when we use this with the CLI config module, like I said, this is an agnostic module that will select the correct vendor specific module. And what we're doing within the CLI config modules, we're using the config method. And within that, we can tell it that we're using a template, and we'll give it the template name. So we'll see all of that in the exercise. And with that, that brings us to exercise 4. And so we got all the way to the end of exercise 3. We'll click on the return, and then we'll go to exercise 4. So I'll give you a minute to get going on that, and then I'll start in with the overview. We've got kind of a quiet crowd today. Is there any questions? Anything that's just burning a hole in your pocket to ask? If so, feel free to throw it into the chat or the Q&A, and we'll get right to it. All right. Well, hopefully you've gotten going. I'll just do a little housekeeping here. All right. So the first part of this is we're going to create that group vars directory. And then we're going to add some information into the all file. And so if we going to go ahead and I'm just going to use VI because that's what I like. But like I said, feel free to use whatever you feel comfortable with. So we're just going to set the loop back on 2 of these nodes. So if we remember back to our inventory, let's see, if we go back to our inventory file, and that was back one directory, lab inventory hosts. So router 1 is a Cisco and router 2 is Arista. So within our group variables, we're setting the loopback address on router 1 and router 2, or at least we're identifying those in our variable file. The next step is to create a template.j2 file. And this is just telling us it's J2 is just the prefix or the suffix we have for our Jinja files. I don't know how important that really is, but here's our Jinja configuration. So we can see the first and the last lines have the opening bracket with the % telling it that that's Jinja code. And so this is just a simple example of the logic we can put into Jinja, into the template engine. So it's saying for every interface and IP in nodes, and then it's giving us the inventory host name as the arguments. And then we want to do the each host and then dot items. And we're going to paste in the interface and IP address for each one of those. So like I said, pretty simple example. And then the last, so let's see, step 3. So there's a discussion on step 3 about how everything puts together if you are interested in that. So now we're going to do the actual playbook. And if I can type, we'll get there a little quicker. So we're just going to do config.yml and all right. I guess I wasn't in the insert mode. So this is, let's see, and my spacing got all goober because of it. Let's see. So that's 1, 2, 3, 4, 5, 6. All right, I need to put a couple more spaces in there. And there we go. Count my spaces again. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Oh, you know what? All right. There we go. That's how it should look. All right. And so we're going to configure these network devices. The hosts are router 1 and router 2. So we have 2 different devices. And we can see that we're using the CLI config. So we're using that generic config module. So exciting times are ahead of us. And as normally happens when we run the command, all the great stuff goes on outside of view. But when we take a look at the output from the command, we see that router 1 changed and router 2 changed. And so it was able to make those changes. So we can log into router 1 and router 2, really, if we wanted to. But the command here it's in the documentation or in the lab guide. Show IP interface. And then we'll use the old include command, and we'll look for loopback 100. I guess it's not gonna. And there we go, loopback 100. So that's the same file or the same address that we had when we take a look at the network config, group vars, all.yml, loopback 100, 192, 168, 100.1. And that's what we have. So, and we could do the same thing for router. Oh, yeah. So there we go. And that's the end of the exercise. We're moving right along. So I'll go through real quickly the lecture part of the Ansible Tower. Just let me clean up a little bit and find my slides. All right. So we just finished exercise 4. We'll go through the introduction to Ansible Tower, and then we'll take our second break of the day and head into the third hour. For all those that are hanging on, I certainly appreciate it. And hopefully you're getting something out of this. And there was a question in the chat. Well, we covered dynamic inventory, and we don't have enough time today to cover dynamic inventory. But if we go to the old Ansible.com and so we have the Ansible core documentation, and so there's quite a bit of information that goes through how to build inventories, but there's a lot of examples of how to build inventories dynamically. So it's a little too much for this workshop. There's just within the Ansible platform, there's so many nooks and crannies, if you will, that it's difficult to cover every part of it during our workshop. So, where were we? We're back on the slides. And then Brandon, yes, Brandon. So we can, if you want to work with the One Technology team, we can certainly set that up for you. So, yeah, if you just work with the team at One Technology, they'll be able to help get that set up for you. And I'm glad. Hopefully your questions indicate that you're having that you're enjoying the workshop. So, so now we're moving on to the second part of the Red Hat Ansible automation platform. This is the section where we're going to get into Tower. And like I said before, Tower is where we can really scale the automation that we've used in the Ansible Engine. And so if we think about the Ansible Engine, and when we take a look at it, we're running everything on the command line. And so what are the controls that we have on the command line? So we're really left with the operating system security. We're left with operating system methods of keeping people from accessing those binaries, accessing the directories that we're using. And so anybody that has access to those can run any playbook they want. They can see the inventory if they have access. There's really no way. There's a few ways. So we have Ansible Vault. We have some other technologies that we can use with an Ansible engine to make it more secure. But for the most part, Ansible engine, runs on the command line and requires some command line input to make it run. It's not like a daemon that's running in the background, or it's not a constant process that wakes up and checks for something, checks for work to do. Every once in a while, we have to tell it to do work before it'll do any work. Whereas Ansible Tower allows us to secure our playbooks. We can put them into source control management of some type. We can delegate authority to specific playbooks, to specific parts of the inventory. So it provides a lot more control. And I think I stole the thunder from this slide with the role-based access control, but it also provides just a much easier way of launching playbooks, and it provides an easier way to log all of the playbooks that have been run and their output. So if we needed to go back and see who ran this playbook, what did it actually do, we can do that through that. And then we can also layer in with Ansible Tower, we can layer in workflows. And with workflows, we'll see this towards the end. I think it's exercise 8. With workflows, we can structure multiple playbooks to run sequentially, and we can provide a small amount of logic so that we can say, run this playbook, and if the playbook fails, use this other playbook to roll back to a known good backup, or if it succeeds, continue on with the actions that we wanted to do. So we can structure some pretty complex workflow logic into that, and we can use that to match our IT processes. So we've talked about most of this stuff. We have the couple of things that we haven't talked about is the API available with Ansible Tower. And so we can integrate this with other tools. The examples here are ServiceNow info blocks, but this can integrate into the other parts of your organization, the other applications that you're using to manage, to monitor, and automate your environment. So this is just one more step that you can plug into your current systems. It doesn't really, we don't have an affinity to one system or another. The API is there for many different technologies to integrate into. And the other one is the enterprise integrations. And this is where we can integrate into your authentication mechanisms like TACACS Plus or Azure Active Directory. And then you can also set up OAuth authentication and notifications, like I said, with these are some of the examples: PagerDuty, Slack, and Twilio. So very powerful, the Ansible Tower, and it just really extends the capabilities of Ansible Engine. And so this is just a visible representation of the of how everything fits together. So towards the middle, we have the Ansible Engine, and then we have Ansible Tower right above that. So Ansible Tower plugs into the Ansible Engine and uses that as the workhorse, so to speak. And then I also mentioned before the Automation Hub at cloud.redhat.com. So this is where we're going to get our certified collections and our partner collections that have been vetted by Red Hat developers and engineers, make sure they work, and then they're supported by Red Hat support. So if you have any problems with them, and that's the other great thing about Red Hat support. A lot of support organizations are in the break fix support model, where if you call them up with something that's broken or not working properly, then they'll help you out. But as soon as they figure out that you've made a mistake, or especially if you open a case with some vendors on how do I do this, they'll just say, we don't do that. Contact our consulting division and they'll help you out for a small fee. But Red Hat support will entertain all of those cases. So that's one of the great things about Red Hat support that sets it above a lot of other support organizations. So with the Automation Hub, we really have the ability to have fully supported modules. And then we also get automation analytics. And so those are built in to the product. There's nothing additional to pay for. And so it's a couple of great features that you can take advantage of when you get to the enterprise version of Ansible. And then we already talked about the rest of the stuff, so I won't bore you too much longer. So we're going to be taking a look at, with this next exercise, we'll be looking at a couple different things. One of those is job templates. And so it's a little bit of a terminology change when we go from Ansible Engine to Ansible Tower. And when we think about, we were running a playbook. And so when we ran a playbook, we have to have three things to run a playbook. We have to have an inventory to run the job against, and we have to have credentials to log into those devices. And then we also don't have to have the third part within Ansible Engine, specifically the project, even though we were using a project within that network dash workshop folder. So that was what was considered a project folder, project directory. But job templates allow us to wrap around a playbook and set up everything that we need to run that playbook. So we'll see that in the exercise, but this is a way that we can set the credentials, we can set the limits, we can tell it which playbook, we can do a lot of different things that we can also do on the command line through Ansible Engine only. But if we were doing the same thing through Ansible Engine, it would be 15 different arguments that we're passing through the command line. And so you can kind of see how that would kind of get old after a while, especially if you're running playbooks on a semi-regular basis. So we already talked about the inventory. It's just a collection of nodes, hosts. So we have the same function feature within Ansible Tower that we have within the Ansible Engine. Credentials. This is a part that really excites me about Ansible Tower. And within Ansible Tower, all of the credentials get encrypted, and it's a one-way encryption. So a little bit of an echo. So what this does, or what it allows us to do, is we can put credentials into the. I've got a little bit of feedback, Matt.
Sorry about that. All fixed.
No, that's all right. It's don't want to make it too bad for everybody for too long. So anyway, the credentials are encrypted, so that when we go into the console, the Tower console, we can't click on, even though, and we'll see this in the exercise, even though there's a little I button here to, and there's a little I button on the other side, I think of there. Once a credential is entered into the system, it doesn't allow us to extract that credential back out. So it's a very nice way of protecting our credentials. We can do the same thing in Ansible Engine with, like I said, Ansible Vault. But at some level, we have to have some way of decrypting Ansible Vault. And so that information has to be passed to the playbook every time it's run, the secret to the vault. And so, at some level, you're always exposing that when you're using Ansible Engine. And you can layer that over, put that through several layers of protection to keep someone from getting to the actual credentials. within Ansible Tower, it does it all automatically. And then the project, that's what we're really going to be taking a look at in this exercise. We'll be taking a look at all three of these. And the project is just a way of putting a wrapper around a playbook and giving it all of the information. So I know that's the job template. Project. Yes, now I'm in the right spot on my notes. All right, so so a project just really represents a collection of playbooks. And so within the project, this is where we can set up the source control management. So right now, the supported versions or supported source control management is Subversion, Git, Red Hat Insights now is another one, and Mercurial. I can never say that one properly, but those are the 5 source control management systems, source code control management systems that we use or that we support within Ansible Tower. There is a manual method. If you choose that, then you're kind of on your own for making it work. But if you have a different source control management system, source code control management system you'd like to use, there is a way to do that manually. And that brings us to our exercise. So let's, all right. So that's the end of putty for us. And let's see, so we got all the way to the end of exercise 4. And we're stepping on the exercise 5 now. So this is just a little bit of a guided tour through Ansible Tower. So I'll have to go back and find my credentials. And hopefully if all works out well, I get logged in. All right. So let's see. So within the lab guide itself, there's a whole bunch of stuff here if you want to actually read through it at some point, but just the high points. So Ansible version and Tower version, if you ever have any problems, you can click on the little I button at the top, and it'll do use the calsay module to put this out in calsay, but we're using Tower 3.7.3 on top of Ansible Engine 2.9.18. So if you ever have any questions about which version of Ansible and Tower you're running, you can just click on the little I button. And so then we head into the inventory. So this is very similar to what we saw in the flat file. So we have our workshop inventory. We can look at the groups that are in the inventory. So we have the same groups that were in the control or in the inventory file on Ansible Engine. We have our hosts. We have permissions. So these are all the people that have, all the users that have access to these. So admin, B Belcher are listed, and student 2 are listed as system administrators. Network admin and network operator can use these. Network admin from the role and network operator from a team role. So we can see everyone that has permissions to read this workshop inventory. And let's see, groups, hosts, sources. It'll show us completed jobs, should we be interested. And it'll show us the source that we got the inventory from, so we can update as it's being updated, or we can just manually update the inventory. So that moves us on to projects. All right, within projects, so there's very similar permissions. We can set up notifications within our project and tell it how we want to be notified. our job templates that are part of this project, and schedules. So within Ansible Tower, we can also schedule tasks to run at specific times. So this kind of takes the pressure off of using an external timer such as cron or the Windows scheduler. And I don't know how many of you've ever used the Windows scheduler, and it works for the most part, but it tends to skip a lot of times when you have it run on a real frequent basis for some reason. And I'm not a Windows guy by reputation, so I never really dove into why that was. But Unix is a lot more dependable when it comes to the cron function. But we can get away from all that with Ansible Tower by using templates. And so within the detail section, we can also set the source code control management system. And we can see that we can give it the URL for that. We can tell it which branch tag commit we want to use. We can also use the ref spec if we want to. We have place for credentials. So what this will do is we can use source code control management to write our playbooks, keep track of all the changes that were made, and then just use those within Tower. So it makes it very, very nice. Or we can just turn that off altogether. And then the last part. So this is the exciting part. Yay! Credentials. So we have our workshop credentials, and I'm just looking at. So I'll look at the workshop credential now. So we see the credential type is machine. We can click on the little hourglass button, and it'll tell us there's all kinds of different credential types that we have. We can also search for credential types. So the username, so this is a machine credential, EC2-user is the username, and private key. So the private key is encrypted. We can't get to it. And we're the system admin, so we can't extract that private key and use it nefariously. If we look at the Tower credential, so this is a password, not a key. So we see here that the password's encrypted, and there's a show button. But once we enter the password in and save this form, it encrypts it. We can't extract that password. So if someone were to stumble across an unlocked workstation where someone's logged in as the admin, they still won't be able to extract passwords. So very nice system for securing. We can create teams and apply a whole bunch of different permissions to those roles. And so, yeah, Ansible Tower is just makes us able to take the power of Ansible Engine and give it out to everyone else in our organization without fear of, well, don't use this playbook, or don't use this, or don't use that. Everyone knows exactly what they're able to use just by logging in. And with that, that's the end of exercise 5. All right. And I don't see any more questions in the chat or Q&A, but if you have any, feel free to throw them out there. All right. So it's been a little over an hour since we took our last break. So why don't we take a 10-minute break now, and then we'll head into the last few exercises. And I'll be hanging out. If you want to have any questions or want to chat, you can throw it into the chat. You can send it off to the whole group, or you can send it to me privately, or the Q&A. Like I said, if you have any questions, and I'll monitor them over the break period. So, but with that, I'll let you enjoy a couple minutes of silence. or get a drink of water or whatever you'd like to do for the next few minutes. All right, we're getting close to the end of our break, just another minute or so, and then we'll get going again. So if you're chomping at the bit to get going, I just want to make sure everyone gets back from break on time. And it looks like we've had a few people drop off, but I appreciate everyone hanging in with us and going through the exercises. And like I said earlier, if you do need to drop off and you want to log back in later, the system will be up until midnight tonight. So since we are running this on AWS, we have a fairly significant cost in putting these workshops on. So we try to limit the impact of any individual workshop against our overall workshop budget. But as you can imagine, sometimes AWS expenses kind of run away from us. But anyway, midnight tonight, it'll be up. So and we'll go ahead and I'll go ahead and get started. So we got to the end of exercise 5, I believe that was. And so now we're gonna head into exercise 6. Let me find my slides here. All right. So yeah, we got to. So now we're going to talk about job templates. So just real quick, I'll just go on job templates. So like I said, these are wrappers for playbooks. So on the templates section, we have the little rocket ship, and that's how we would launch it. Of course, we have another icon right next to it for copy, and then we have the trash can. If you so if you have permissions to do either of those two options, you'll see that. If not, you'll just see the spaceship for the launch of the playbook. So it makes it really simple to launch playbooks. When we go into creating a new job template, we'll click the little green plus button at the top of the screen, and it's going to give us the option to create a new workflow or create a new job template. We'll want to select new job template, and then we'll have to fill out all of the required fields. So if we think back to the introduction to Ansible Tower, the 3 things that are required are the inventory, credentials, and a project. We also have to give it a name, and some of the other stuff is already filled out for us, like verbosity and job type. Those are already set by default to run in normal, but we can change those as well if we need to. And that brings us into the 6th exercise. So as I promised, the slides get less and the exercises get to be more. So we have 4 exercises left, and we have about 40 minutes or so left. So we'll run through these as quickly as possible, but you may need to, or we may not have enough time to do all of these. So all right, so exercise 6. So there's where that is. So I will switch back over to my tower, and so I didn't log out. I just stayed logged in. So hopefully everyone did the same. I just went back to the dashboard just to give a common starting place. And so we're going to go to templates. And we're going to click on the plus button. So now we have the option of job template or workflow template. We want to do a job template. And we're going to give it the name. So we're going to call it backup network configs. We're going to set this to run. So we have the option to run or check. So there's that place where we can set the check option if we wanted to run this in the check configuration just to see what was going on. The inventory, so we can type something in there, or we can just click the search button and go to workshop inventory. That's our only inventory right now. It went ahead and selected the project for us, but if we had multiple projects, it would let us select that. The playbook we want to we want to do is network backup.yml, and then the credential. So we want to, so here at the credential type, we can select all of the different types of credentials that we have. So we have a workshop credential, and we're going to go ahead and select that. And then we also want to go back in, and so we're going to choose Ansible Tower for a credential type, and we're going to choose the Tower credential. So now we have 2 credentials loaded. And the reason why we need these 2 credentials is even though Tower is on the control node, we don't have permissions automatically just because we're in Tower to the Tower system. So when we look at the network backup.yml file, we will see that it's taking those backup configurations from a router and then placing them on the Tower system for storage. And so we need a credential for the system that we're going to store these on, as well as the credential that we need to log into the devices itself. And we're going to run down here to the bottom, click on save. It's going to save this job template. So we can go back to job templates, and we can see now we have this button. We can launch it, and as soon as we launch the playbook or launch the job template, it's going to bring us out to this very familiar output that we've seen before. And so as we watch it run through this, we notice that some of these are highlighted. So just a little bit about as this is running. So on the left-hand side, it shows the details of the job template. It shows us when it was started. When it finishes, it'll show us a finish time. It'll show us who ran the job template, which revision we're working against of the playbook. And so I'm just gonna take a little side. We'll go. So if we were to open this in GitHub, so here's all of our playbooks, and so we see network backup is the playbook that we're using, and so we can see what this is doing. It's creating the first task is it creates a timestamp using the set fact module, creates the backup directory on the control node, creates a timestamp directory, retrieves the router configurations, does the backup, saves that configuration locally, and then there's also a create restore job template as well. So that's what it looks like in the source control management system. So we'll go back to templates. We see that it was ran once. So we can go to jobs now, and we can look at the output from this. So this is where we were originally. We see on the left-hand side all the details. So now we can click this expand output button, and we can pop this out a little bit more so we can see more information. It shows us the timestamps of how long it took for each task to run. And the other great thing is that we can click on anything that's colored. And so we can see the JSON output from this. So we can see for let's see which. So this is for Ansible one. This is setting up the control node. So this is where the names come in very handy. So we see the task is create backup directory on the control node. This is just all the information that gets passed back and forth between the control node and the server that we're communicating with. So this is very helpful for debugging. If you're starting to have problems, or if you have problems with your playbooks, Ansible Tower makes it very easy to go in and troubleshoot these. So we have the blue color for things that are skipped, so we can see all of these things were skipped. We had some changes. So at the end, we can see we had 3 changes on our Ansible node. We had 3 changes on router 1, and then 2 changes on each of our other routers. And we can, like I said, we can go back to the jobs, and we can look at these previous runs. So if we have any, if we want to look at this later, we can go back and look at the playbooks that were run and what their output and status was. So this is a great way on the compliance front that we can verify that changes are being made properly. We can also, if there's a requirement to remove an employee from, remove access, we can use these Tower job records to document that all those changes were actually made. So it makes it very handy for the verification of what's been done, and also in compliance. And that brings us, I think so the next, the last part of this is just to, let's check to make sure that we had a backup directory. So there we go. There's our backup directory, 2021-03-17-1720, which is the time it was created. And let's see what time. So I've been time. I always do that on darn Linux systems. Type time and it's date. So anyway, so you can see about 5 minutes ago I ran that. And if we look here, we have router 1, router 2, router 3, router 4. These are the configuration files. So if we take a look at router 1, I'm going to pipe it to less because it can be very long. But this is our configuration backup from our Cisco router. We can go all the way to the end, but I won't torture you that much. And we can see, router 2 is the Arista device, and we can see that it has a much different format from the Cisco IOS. Different in a way, but similar in a way. And then if we look at router 4, which is the Juniper, so here's nope, that's another Arista. Let's look at number 3. Maybe number 3 is, yep, this is the Juniper. So so we can see three very different configurations use the same playbook to address all 3 of those and get the information that we were looking for. So very powerful part. And that brings us to the end of the exercise. All right. Let's go back to the slides. So exercise 7. So now we're going to do a couple of different things. We're going to build a job template, and we're going to use these extra variables that we're putting together. And then we're also going to take a look at building Tower surveys. And so surveys within Tower are a way that we can get user input without them having to modify the playbook itself. So it's a way that we can get input from the user that's running this playbook, but the user doesn't have access to the playbook itself to make those modifications. So this is a survey. The example survey on the screen here is when you're adding a VLAN, what are the two things you need to add a VLAN? Well, you need the VLAN ID and you need the VLAN description. So those are the two things we want to make sure get entered every time. So those are required fields. So when someone launches this template to add launches this job template to add a VLAN, they'll be presented with a pop-up that will give them their two questions they need to fill out. So when we create a job template, this edit survey button, or it'll be add survey to begin with, and then once there's a survey created, it'll be the edit survey. And then that'll pop up a new window, and we can configure the survey. So we can put the prompt, the description, the variable name, the type, and we can also add some length to that. We can add a default. And then what we'll do, it'll be more apparent in the exercise. We'll click the update button, and then there'll be another button to add additional fields. And so once you get all the fields, I want to scroll down so bad. Once we get all the fields, there's a save button over here on the other side. So we'll see how that all works in the exercise. So then when we launch the template, the survey is going to pop up, and then it'll tell us, give us an indication of what we're looking for. So the example that we have in the exercise is this configure banner playbook. And so that moves us into exercise 7. All right, we're speeding right along, but we're still not on track. So, all right, so let's see, we got all the way to end of exercise 6. And now we're heading into exercise 7. So, yeah, I'll give you a minute to get oriented, and then I'll get going. All right, I don't know if that was a minute or not, but I'm chomping at the bit to get going. So what we're going to do is we're going to go to our templates. We're going to create a job template, and we're going to call this one network dash banner. I've really I spent a lot of time coming up with these names. So just kidding, it's part of the workshop. So we're going to be working against the workshop inventory, so it automatically selects our project because we only have one. We're going to use networkbanner.yml. And for our credentials, since we're not storing anything on the tower system, we don't need the tower credential. We just need the workshop credential this time. And so the next part is to go in and look at the source code. So here's the playbook that we're running. So we're setting the network banner, and so we're using the this is the variable name that we're using, and if there's and then we're using the pipe as an or the default is none. So we will have 0 banner if we don't type one in. And then we have our net type, which would be the banner type. Net type is the variable. Default is login. And we'll see as we work through some more of the exercise. So I always like to click on save just to get going. But when we save it, it's going to allow us to add a survey. And let's see. Let's see, and then net underscore banner. So we need to have a little bit of coordination. We're going to choose text area, and it's required. And then we're going to click the add button. So that's going to put this into this side. So here's our first prompt, and then it gives us the ability to add another one. So we can just keep adding. So we're going to please enter the banner type. And we're going to say, please choose an option. And this is going to be net underscore type is the variable name. The answer type is going to be multiple choice, single select. So we can also choose multiple choice, multiple select as well. But we just want to be able to provide one option, or we want them to have one option. So our first one is login and then a message of the day. And the default option is login. And this is also a required field. So we're going to click on the add button. So now we have our two prompts that are going to be. We're going to click the save button here to save the survey. And then we need to save again to save the overall template. And we could launch this right here from this launch button, but I like to show off the rocket ship. So we have our network banner job template. We're going to click on that. And here's our survey. So if you were to think about giving permission to other teams to make pre-approved changes, and where this really comes into, where these surveys really help out is, one great use case is a security operations center. And, within a security operations center, we need to move as fast as possible every time we identify a threat. And so this is a way, setting up these surveys is a way that we can, and using Tower is a way that we can give our SOC personnel the ability to make small pre-approved network changes to respond to security incidents, and makes them more efficient. And then someone in the network team can follow up to make sure that that's an appropriate change, or whatever the case may be. But for here, we're going to type in something to be the message of the day, or the login message. So there's the example to put the ASCII art. If you want to put ASCII art in there, that's great. I have never put together what needs to be in it. For some reason, they just included a picture in the lab guide. So we'll click on next, and then when you click on next, it'll give you a preview. It'll show you everything we're doing, but it'll show you, more importantly, what you typed into this field. So it gives you one last chance before you click the launch button. And so there we go. So this is going to run against all the hosts in our inventory. So the task was add the Juno OS banner. that was changed. Add the EOS banner to routers 4 and 2, and then add the iOS banner. So we have 4 different routers, 3 different vendors. And if we type in here, if we go to router 1, we can see that now Ansible Tower has changed my life. Or if we go to router 4, there we go. So now we have our login message set. So, think about something like this in the context of needing to update the login message. Maybe you want to reference a local law that's just been updated, changed, added, and you need to reference that in your login message. We can use Ansible to go out and make all these changes for us without having to log into hundreds of devices to make these changes. So very powerful capabilities within Ansible. So that brings us to the end of exercise 7. All right. So we have 20 minutes left, so we really have like 10 minutes left. So I'm just going to go through exercise 8. Is really about understanding the role-based authentication within Tower. So I don't know if we need to work through it. It's not too time consuming. It only takes about 10 or 15 minutes to go through. But since we only have that exact amount of time left, but role-based access control, just like every other product that has it, it's very, very similar, I guess I should say, to other products. Fairly intuitive interface, excuse me, but there's just a little bit of a different terminology within used within it. So if you're not familiar with it, so we have organizations. So we can have multiple organizations within Ansible Tower. And so an organization, logical collection of users, teams, projects, and inventories. Then within the organization, we have teams, and the teams provide ways that we can segregate users or put them into meaningful groups. And then we have users, and that's where we can have the final level of control. So we have 3 levels of control for access that we can work with. When in the exercise, you'll be viewing the organizations and taking a look more about the different organizations that we have set up. There's either 2 or 3. I don't know if there's all 3 of these set up in our demo or our workshop. And then we can view teams, and then users as well. And we've saw most of that already. And let's see. I know I just said I'm not going to do this, but just so we have kind of a common way of thinking about it. So here's our organization. So yeah, we have 3 organizations. Within our organizations, we have, in our default organization, we have 0 teams, 1 inventory, 0 projects. But over here in our Red Hat Compute organization, we have 2 teams. And then our Red Hat Network organization, we have 2 users, 2 teams, 1 project, 1 admin, 9 job templates. So that's where everything is organized right now. And then we have our teams, and we can see which organization they're a part of. And we can go into any one of these and see more details. We can see who the users are that are assigned to each of our teams. And finally, we can see our permissions. And this is we saw this in the inventory permission inventory and project permissions, where some users had the ability to use the inventory through the team role, and also some were specifically granted that. We can also go through and look at the individual users. So it looks like the Belcher family is working at this. Looks like this is the Belcher family organization. So Bob, Jean, Luis, and Linda, and Tina. Oh, look at that. So here's all the information about these, about each user. And you can see that we can only change the password, but we can't see what their existing password is. So if they were to forget the password, an admin can come in and set the new password for them, but we can't extract passwords. So another great feature. And that's the long and short of the little journey we have there. So just in the interest of time, so we're going to go a little bit through. So I'm going to go through the lecture part of this, and then I'll bring on Matt to give us our wrapping up comments, and then I'll stay on after, or maybe I don't have enough time. I actually have another meeting. I have a hard stop at 1 p.m. or at noon, as the kids would say. So I'll go through the logic, and we'll do as much as the lab as we can. So the understanding workflows. So we'll click on the little plus button there, and we'll select workflow template. And so we'll have to fill out a couple of pieces of information, name, and our inventory that we're working against. And as soon as we click on save, it should bring up the workflow visualizer, but if it doesn't, we can click on the button. It's going to bring up with a blank canvas, and from there we can add playbooks or job templates to each one of these, and then we can create branching logic. So I said we can have a branching logic if a task succeeds or fails. So if it's a blue line, the job template will always run. Green means that it runs on success of the previous template, and red runs on failure of the template. So we can see we have some simple logic here. We're going to back up the network configuration. Once that succeeds, we're going to configure the banner and a network user. And then we're going to restore the network config if either of these fail. All right, so that brings us into the exercise itself. And so that is on, we got all the way to the end of exercise 7. We kind of skipped over exercise 8 just in the interest of time, and then we're on exercise 9. So with that being said, I don't know if Matt, if you're still out there, if you had the desire to hop on and give some closing remarks, and then I can stay in for a few more minutes and work through this.
Yeah, Marshall, thank you very much for leading the workshop today. We definitely appreciate it. One Tech, Red Hat, and then all the participants. So thank you for everyone who joined. This will be recorded and sent out so that you can share the highlights with your team. If you decide you want to do an event like this internally to your organization, let us know. We're happy to facilitate those as well. But yeah, thanks to everyone. And let me see if there's any questions real quick. I think if not, I think we can probably I think we'll probably be able to close it up here.
All right, fantastic. Well, thanks so much for hosting today. And if anyone has any questions, feel free to reach out to the One Technology team, and they'll be able to get you in touch. You can theoretically contact me directly, but we don't want to sidestep any of we want to make sure everyone gets taken care of and doesn't get lost in my inbox. So. But yeah,
perfect. Marshall, I'll have you copied on the note to everyone who participated with the follow up with the links and all that. So we'll make sure that everyone's got the ability to reach everyone else.
Perfect. Well, thank you so much. And with that, I guess we'll wrap a few minutes early.
Awesome. Thanks, Marshall.
All right. Hey, thank you.
Bye, everybody.